Hey everyone, welcome back for some more math. Today we're going to be learning how to write linear functions using point-slope form to write the equations of lines, and then what we're going to do is convert it to slope-intercept, and we are going to write equations of parallel and perpendicular lines. So we'll talk about what the slope of a parallel versus perpendicular line is. So first things first, I set this up in last notes for you guys, but we didn't do anything with it. And that is that point-slope form gives you a point and the slope. And the point is x1, comma, y1. Okay, so the y1 goes over here next to the y, and the x1 goes over here next to the x. And then one thing I'm going to say about this, the point, is it is always going to have opposite signs because this is being subtracted and this is being subtracted. So that's basically going to flip everything. So if you put a 4 in, it's going to look like a negative 4. If you put a negative 4 in, it's going to end up looking like a positive 4. Because when you subtract negative 4, it turns positive. Then there's the slope. So the m right here, just like in y equals mx plus b, that's the slope. And I'm going to remind you that it is rise over run, or another way of thinking of it is the change in y over the change in x. Again, that little symbol, it's called delta. It means change in. You'll see it a lot in physics class if you take physics. Okay, and then for point-slope form, realize that you must always have a point and the slope. The main difference between this and y equals mx plus b is that that point doesn't have to be the y-intercept. In y equals mx plus b, it does have to be the y-intercept. Okay, so now we're just doing any random point on the line. And realize there are a bunch of options on every line. Okay, so we're going to practice writing the slope-intercept equation of each line using point-slope form and converting. Okay, so we have to start with this, and then we're going to solve for y, which isn't really that difficult. I'll explain how it works. So I'm going to write the formula right here, just so that you guys can see it at the same time. You do not have to rewrite this formula every time, but if you are stuck on a problem, that is what you should do first, okay? So this is going to be my slope, so m, and then this is going to be my x1 and my y1. And I'm just going to go replace them. So this is going to be y minus y1, which is 4, equals m, 3/2, x minus x1, which is negative 3. And I'm sorry, my pen got in the way. That made that blurry for a minute. Then, when I have minus a negative, that's basically the same thing as adding. So notice how this 4 became negative and this negative 3 became positive. That's what I meant when I said always the opposite signs. Okay. Then, to solve for y, we're going to start what you would start with in any normal equation and distribute this 3/2. So that's going to be 3/2 x. Don't worry too much about that. We actually want there to be a fraction in front of x because that's the slope. And then 3/2 times 3 is going to be 9/2, or 4.5 if you really want. Okay, and then I want to get y all by itself, so I need to add 4 to both sides. And then I'm actually going to show you this one in a calculator because I know some of us are struggling with that. So if instead of writing 9/2, what you want to do is 3 divided by 2 times 3. Okay, and I have kind of an old calculator, so it looks a little funky on here. And that's actually 4.5. So if you wanted to write 4.5 here, you could. And then 4.5 plus 4 is 8.5. And I don't care if you guys write it like that or as 8.5. Either one of those is fine with me. I'll put an or here so you know it's not both. And basically what that means is if we wanted to go graph this, we would start at 8.5 on the y-axis and go up 3, right 2 to graph the line. And it's so much easier to graph this than it is to graph this. Okay? So we have a more useful equation of the line. Alright, what I'm going to do is go ahead and do a graph so you can compare the processes and then do the 2 points. And I only have a second version of these two because they're a little bit more challenging. So, using a graph, all you do is pick a point. I'm going to choose this one. It is 2, 1. Okay, so that's my x1 and my y1. Then I need to count my slope going from one point to the next. So this line is going up 1, 2, 3 over 1, 2. So my slope is 3/2. And then all I do is y minus y1 equals the slope x minus x1. Okay, y1 was 1, x1 was 2. Then I multiply, which I ended up having 3/2 again. That's just going to be 3/2 x. That is always going to just be this number in front of x right there. Then 3/2 times 2, negative 2. 3 divided by 2 times negative 2. Hey, what's up?